What's poppin', dogs? Mr. Allen here with what's called a walk-around problem. Now, that might be more of a street term, not an official math term, but you're going to see why we call it a walk-around problem here in just a moment. So what we have is a quadrilateral that has been circumscribed about a circle. Inscribed is when it's in the circle. Circumscribed, careful how you say that, outside, around the circle. Okay, cool? And it lies tangent at these 4 points. Okay, a lot of times they'll even say in the directions or the prompt that the lines that appear to be tangent are in fact tangent. But I also stated up here as well, AB, BC, CD, and AD are tangent to circle E at those 4 points. Now, we're also given some lengths here. AD is 11. We have CD down here. CD is 16. And then I have BC is 14. Okay. It's always a little tricky to like label the larger segments, you know, when there's other points in there. So I often do the fancy teacher brackets. If you can't do those, it's okay. Take a little practice, right? Teacher brackets, I mean, you got to perfect them, okay? They look terrible at first, but you'll get there. I believe in you. So I want to figure out what AB is right now, okay? I don't know what it is. Let's see if we can figure it out. Well, here's the thing on this one. There's a couple ways of going about it. Right? I'm going to show you the algebraic approach, and then there's a little shortcut way that I'll show you at the end, but it only works for this particular scenario, okay? And sometimes we have triangles that are circumscribed about the circle, or maybe a 5-sided polygon, a pentagon is circumscribed about the circle, or maybe even inscribed. And the algebraic approach is going to be more universal. So I'm going to show you guys that first. Now, when we're doing that, I'm going to switch to, we'll go pink. I can pick, okay, any spot on this diagram to start. Totally up to you. The answer will work out the same. I often pick out one of the further corners here from the unknown segment because the algebra is a little bit easier. So I'm going to start over here on this like corner of the diagram. I'm going to call this segment right here X. Okay. So if that's X, then what is this guy right here? Well, the whole segment is 11. So just this section right here is 11 minus X. Right? Whatever this length is, I'm going to subtract it from the 11, and that's what I'm going to get for this guy. If this is 7, then this is 4. If this is 8, then that's 3. So on and so forth. Okay? So where do I go from here? Well, the tangent thing. That's important. So for tangents, there's called a two-tangent theorem. When they're drawn to an external point, a common external point, these two segments here are congruent. So if this is X, then this is also X right here. If this is 11 minus X, then this is also 11 minus X right there. Cool. Well, I don't have anything else to go off of over here, so I'm going to walk around the other side of this quadrilateral that has been circumscribed about the circle. Well, this is X. Could I do the same kind of thought process I did up here? Absolutely. This is going to be 16 minus whatever that X is right there. And by my two tangents, I've got this guy is congruent to this guy, so this is 16 minus X. Now, here's where the algebra gets a little messy. It's not terrible, though. This is 16 minus X. This whole thing is 14, so this is going to be 14 minus the 16 minus X. Got to be real careful here. So I'm going to write it all up. We have 14 minus the 16 minus X. Okay. So I got to distribute that negative to get 14 minus 16 plus X. So I'd have negative 2 plus X. That's what this segment is right here, negative 2 plus X, which would mean that this guy right here, negative 2 plus X as well. Right? The two tangents applies here. So we're applying the two tangents as we walk around this whole figure. So now what? Well, let's just say this length was 3 and this was 5. The whole thing's 8. How did I get that? I added them together. Could I add these two together? Absolutely. 11 minus X plus my negative 2 plus X. And I know this looks a little weird with the negative, but I'm going to roll with it just to show that we are indeed adding these two segments together, right? We're adding the two segments to get the full segment, a little segment addition property, if you will. So I have 11, negative 2. That's going to give me, what, 9? What happens to my X's? They cancel. So that means that AB equals 9. Yay! Final answer. Boom. It's pretty dope. Pretty darn dope. Cool. It's awesome. So walk around problem, using your two tangent property and also just picking a random spot to solve. I could have started here with x and x. I could have started here or even there. If I start up here on the partially known one, then this algebra, I got to do this whole like little thing twice in the process. By starting on one of the far ends, I only have to do the whole subtracting of that binomial one time. Okay, so it makes the algebra a little bit more simple. Now, as for the shortcut, which I promised, right? I promise I'm going to hold true. You're going to be like, bro, why do we just do that? Again, this only works when we have the quadrilateral that has been circumscribed about the circle, okay? So if you see this scenario, feel free to go for the shortcut. As long as your teacher's cool with it, they should be, right? It works. But have the algebra in your back pocket because the algebra is more universally applicable. If I add 11 and 14, okay, 11 plus 14, the opposite sides there, and I subtract the other one that is opposite the unknown, I'd have 25 minus 16. That's 9. Okay? So by adding the opposite sides and subtracting the one across from the unknown, you will get to the same answer. Super quick, easy way to do this particular one. And it is always going to work out that way. There's a way to actually prove that it's going to work out. I'm not going to do that now. But again, only works with the cyclic quadrilateral. No, that's when it's inside. The quadrilateral that has been circumscribed about the circle. So this particular diagram does work like this. Algebra, more universal to any type of scenario. All right? Well, thank you guys for watching here. Feel free to ask any questions in the comments, or if there's like a video like, hey, do you have something like this, or can you make one? Let me know. But otherwise, have a great day.